So, well, and then we're too. All right, so, there's all your notes on it. So there's like this YouTube video that shows you how this works, but we don't really have time for that, so you don't get to see it. Sorry, not sorry. Just Google it if you really want to know. Or I can like send you the link. You can watch it on your own time. But basically, it just shows you how a function is moving through time. So you're going to have like your x equals function, your y equals function, and then you're going to have a t variable in there as well. So that's just telling you your time. The t is called your parameter. That's basically the only thing that's new. So if you're asked to eliminate a parameter in an equation, that just wants you to rewrite all the stuff you have without the t. And we're going to do that on some at the bottom. So the first thing that we're going to do is we're going to graph them. So when you're doing this, you've got to make a new table. And you're going to plug all your t values into both the x function and the y function. And then we're going to plot the x and y ordered pairs. Does that make any sense? So when we do our little table, you're going to have t, x, and y going on. That okay? So they're probably going to give you an interval. Not probably. They are going to give you an interval if you've got to graph them. Ours is from -2 to +2, so we're doing all the numbers in between. -2, -1, 0, 1, and 2. So like I said, we're just going to plug all these into the functions that they gave us. So if you plug in a -2 for t into x, -2 squared gives you what? And 4 times 3 is 12. Is that okay? So let's plug in a -1. What is -1 squared? And 1 times 3 is? That okay? Everybody still with me? Are we going too quickly? Alright, so then plug in a 0. What is 0 squared? And 0 times 3 gives you? 0. If you plug in a +1, what are you going to get? 3. If you plug in a +2, what are you going to get? 12. It's a parabola because it's squared, right? So those values are going to repeat in your table. Then if you're looking at your y's, we're going to plug the t's into our y function now. So -2 times +2, what do you get?
4.
-4. When you plug in a -1, what do you get?
-2.
When you plug in 0, what do you get?
0.
When you plug in 1
2.
and +2?
4.
Questions on any of that? So you've got to get that table before you can graph them. So now we're going to take those x and y pairs, and that's what we're plotting on our graph over here. Is that okay? So you're going to have the point 12, -4. So 12, -4 is about here. It's so far away. Then we've got 3, -2. We're going to have 0, 0, 3, +2, and 12, +4. Now, normally we put arrows on the end of this graph, right? But because our interval is only from -2 to +2, you're just going to connect your points and you can't go any further, so no arrows on the end. You're going to stop at those endpoints, and that's it. So that's our whole graph there. Is that okay? And so what this shows you is that this particle or whatever is going to move this direction over time. So like I went and drew little arrows on mine just so we could kind of tell how it was happening. So that's what parametric functions show you. Is that okay? Questions on how to graph them? Alright, you're going to have 2 like that on your test, so I hope that we're good there. You just make a table and then plot new points. Is that good? Alright, so now I want you to find the rectangular equation for that parametric curve. So this is where I was saying you eliminate the parameter. So basically, just take your equations that you're given. Which one is going to be easier to solve for t? The x or the y? The y, right? So we could say that we've got y equals 2t. So solve for t, what do you get? Y over 2 equals t. Is that okay? Make sense? Yes, no, maybe? So then we can plug this back into our x function. So we'll say x equals 3 times t, but we know that t is y over 2, and it's all squared. Are we okay with that? What's up? Because that was the way that our particle moved, so it's just showing you how it moved over time. It's not going to actually be there on your graph. So you don't have to draw that. Right here, when you have y over 2 squared, what does that become?
Y squared over 4.
So we've got 3 y squared all over 4. They may want you to solve that for y, so that's what I'm going to do. I'm going to multiply by 4, then divide by 3, and so we'll just have 4x over 3 equals y squared. So I'm not really sure how far they're going to want you to take it, so you just need to be able to take it wherever they want you to. I would imagine they're going to solve for y if they can, because that's just typically what we do. So the thing to remember for these is just solve the easier equation for t and then plug it into the other. So I'm going to make a note of that over here so that y'all can remember how to do this later. That would be like our final answer there. Alright. Is that okay? Here? 2 squared. Is that alright? Any questions? Alright. So the next section, we're just going to continue to eliminate the perimeter there. Blah, blah, blah. So it wants us to find the rectangular equation for the plane curve defined by these parametric equations, and then we're going to determine the domain. So looking at our functions, which one's going to be easier to solve for t? I think y is easier, but really either way here is fine. If you look at x though, how would you get t by itself? Just divide by 4, and then over here we could just plug that in place of t. So it's actually a little bit easier to solve for x on this one, but either way, you'll still get there. So do y'all want to solve the x or the y? Whichever one you want to do. Y'all tell me. X or y? Y. That's the one that I did. It's a lot more work, but that's okay. So then you could say y plus 3 equals t. So then we'll come back over here where the x function is and say x equals 4 times t, but we know that t is y plus 3 now. So then when we simplify that a bit, we've got x equals 4y plus 12. And typically we want to solve for y, right? So we would need a minus 12 and divide everything by 4. So that's going to give you y equals negative 1. Wait, is this backwards? No. Nope. 1/4 x minus 3. That's just solving that for y. So I minus the 12, divided everything by 4. Is that okay? Minus 12, divide everything by 4. Yeah? Okay, so that's going to put you there. So that's 1/4 x minus 3. So that, which is a little bit easier if you solve this equation for t first, because then you could just plug it in here. Either way, it doesn't matter. So that's our function. We want to know our domain now. So for your domain, we know that that's talking about x values. So the x values are going to be determined by your t. So what we're going to have to do is plug in these t's into our x function. That's going to give us our new domain. So we're going to find the value of x at 2 and negative 2, since that's the domain they gave us for our t's to start with, or the values for t they gave us to start with. At negative 2 and 2. And since it's just a linear function in between there, we don't have to worry about anything funky happening. So you can just find the end, the beginning, and that'll be our interval that we can put all this on. So if we plug in negative 2, we're going to have x times, or x equals 4 times negative 2. And what do you get out? Negative 8, and then we're going to plug in a positive 2, so x equals 4 times positive 2. What do you get out? Positive 8. So your domain here is going to be from negative 8 to positive 8. And that's it. Is that okay? So here's your function without the parameter, and there's your new domain. That's all we had to find there. Questions? So for the next one, we are going to eliminate the perimeter there as well. So we've got x equals 4 cosine of t and y equals 3 sine of t. So we're going to kind of solve both of these for t and then see what we could do from there. So for this one, well, we're not really solving for t, but we could divide by 4. So So then say that cosine of t is x over 4. Is that okay? And then for the sine function or the y function over there, what could we get there? Sine t equals y over 3. So then at this point, we're going to use the Pythagorean identity, sine squared plus cosine squared equals 1. Do you remember that one? So that's basically like all you could really do with these. So if you're given a sine and cosine and you've got to eliminate the perimeter, that's probably how they want you to do it. So we're going to square both of those. So we'll say that cosine squared of t equals x squared over what? 16. So then sine squared of t is going to equal what? Y squared over 9. And we said we would do sine squared plus cosine squared equals 1. We're using that identity, so I'm going to write that here so we know where this stuff is coming from. So given that, we could say y squared over 9 in place of sine squared plus x squared over 16 in place of cosine squared equals 1. And now our perimeter has been eliminated because we don't have t's in there anymore. Is that okay? Yeah, and what type of conic section is this? The next thing we're going to talk about. Is it a circle?
So, the problem where?
I mean, it's either going to be a circle, a parabola,
Ellipsis.
an ellipse, or a hyperbola. Which one?
Ellipsis.
Why is it an ellipse?
Parametric.
Oh, you're adding.
Because you're adding, you got x squared and y squared, and there's different numbers on the bottom, so that's going to be an ellipse. If you had the same numbers on the bottom or like in front of it, it would be a circle. Yeah. So this is an ellipse. I think it's helpful to go ahead and recognize that. E-L-L-I-P-S-E. And we could graph that if you wanted to. But we're not, because we don't have time. So, moving on to the back. You ready?
Wait. One above that, problem above that, how'd you do the sum for y though?
It doesn't matter which one you do. Just pick whichever one looks easier. Are you talking about here?
Yeah.
Typically, they solve equations for y. Like, if it's just in math, we like to have y by itself. So that's why. Does that make sense? So, it's going to depend on, like, what your answer choices are, but they're probably going to have you solve for y. Okay? Any other questions before we move on? If you don't have your calculator, you need to go get that right now. Go, go, go. So, for the rest of these, we're kind of going back to like math 1, math 2, math 3, whenever you did all this like projectile motion stuff, and you want to know like how high is an object after however many seconds, or when does an object hit the ground, that sort of thing. But you've got parameter equations instead this time. So for these, anytime they're talking about distance, or your x function is going to give you distance, like your horizontal distance. So I would highlight that because that's going to be helpful to know. So the x is giving you your horizontal distance, the y is going to give you your height, and t is going to be your time. So that's a little bit different from what we normally think of with these types of problems, because like back when you've done these before, x has always been your time, right? But we've got two different functions that are modeling all this going on. So your x is now your horizontal distance. So if it's asking you how far something has traveled, that's like your x now instead of the time. Does that make any sense? So we're going to do some of these. So it says that an object is thrown at an angle of 45 degrees. Given these parameters, find the following. This whole first part doesn't really affect us right now, so don't worry about it. We just need your functions. So this x function is going to give you distance. So I'm going to go ahead and write that below it, just to keep things straight here. And the y function is going to give you height. So part A here wants us to know how high will the object be after 1 second. So which function are we going to use? Y, because it's talking about how high, that's your height, right? So plug 1 second into this function. Tell me what you get. Can we do that? So I'm going to write out what we're doing just so that we know where this number came from and it's not just some random number thrown down on our paper. I'm sorry? It doesn't matter. There's no trig, so it doesn't matter. What did we get? 15.5? Is that okay? Whatever you want it to be. We don't have any. So feet? Let's see. That okay? Do we have questions on that? Does it kind of make sense how that's working? Yes, no, maybe? Y'all give me something. Tell me how we're feeling. Do we understand? Yes or no? So it asks for a height. The y function is going to give you height. So just plug in 1 into your height function. That's all. Is that okay? The next one, it says, when does the object hit the ground? So if something is on the ground, what is its height?
0.
0, right? So you're using your height function. We want to know when it's going to be 0. So what you can do is just graph that one and then analyze the graph for zeros. Y'all know how to do that? You should know how to do that. I'm going to see, I'm all right, when y equals 0, so we know what we're doing here. So go to your calculator, go to a new graph, type in your y function. So instead of t's, what are we putting in? X, because your calculator doesn't like t's. So negative 16 x squared. So we can like estimate where we think those zeros are. Do you see your zeros? Where you cross the x-axis? So here and here. Yes, no, baby? Yes? So how do you figure out where they actually are? Then what? Analyze graph. How do y'all not know how to do this?
I did.
And then choose zeros?
Isn't this 0 too?
No,
Wow.
because it doesn't cross at 2. You've got to get the exact answer. It's like 1.97, which is close to 2, but not exactly 2. So you've got to figure out exactly where those happen.
Is it exactly 0?
Yes,
So 0
should be.
and what?
0 and 1.97.
So it's good.
But we want to know when it hits the ground. So is that going to be the first 0 or the second 0? The second one, right? Because the first one is where it's leaving the ground. That's not super helpful. We want to know when it hits the ground, when it comes back down. So that's at 1.97 seconds. Yeah? Questions on that? Have we done this before?
Yes.
You should have. So I'm literally doing this in Math 1 right now. So that was like 5 years ago for y'all practically, right? It wasn't that long ago, but it was a long time ago. Long enough. Is that okay? Questions? Yes, no, maybe? Okay, so the next one wants to know how far the object has traveled when it hits the ground. So if it's talking about how far, is that a height or a distance? That's your distance. So which function are we going to use, the x or the y? X. So when it hits the ground, so when did it hit the ground? At what time did we hit the ground? 1.97, so plug 1.97 into your x function. And you should get 62 point what? So 06? Is that okay? Questions? Is there anything that we are not sure about or don't understand? Alright, so the next one is much of the same thing. So this time a shirt is launched from a t-shirt cannon. At a basketball game, the object's path can be modeled by your following parameters. So how high is the object after 4 seconds? So if it asks how high, which function are you using? Your y function. And it wants to know after 4 seconds, so what are you plugging in? 4. So take your y function, plug in 4. $288, that okay? Questions there? The next part wants to know when it hits the ground. So when you're hitting the ground, what are we thinking? When what is 0? When y equals 0. So when y equals 0, what time is that? What is our t value? So again, you can just graph this guy and analyze the graph for your zeros. So do that right now. Apparently we need some practice with that, so you should all be having your hands on your calculators, typing that in on a graph, analyze the graph.
Well,
Do we need to I think we're gonna have to zoom and stuff. Do we need to review how to do that?
when you put it in, it's going to go in a straight line, but yeah, go zoom out.
So when you graph it, you get this, which is not helpful because we can't see when you hit the ground. Do you agree? So you've got a couple options. You can do like zoom fit, or you can zoom out. Zoom fit doesn't always work. Sometimes it works really nicely, so it's just kind of a gamble. So it did a little bit, but it went so far down, we don't need all that. We need the 0 over here, so you're gonna have to zoom out a bit more. So then once you can see your zeros, you can analyze your graph for those zeros. Does that make sense? So do that. So at what time do we hit the ground? 12 seconds, or we're assuming it's seconds. So then how far has the shirt traveled when it hits the ground? How do you figure that out?
Plug 12 in, t is 27.
So you're using your x function this time because it says how far, so that's your x function. And we're plugging in the time when it hit the ground, so 12. So we could say x equals 27 times 12. And what do we get? 324. So that's how far it has traveled. Is that okay? Listen, maybe? Questions? So the last part, it wants to know when the shirt is the highest in the air. So if it's talking about the highest point, what does that make you think of?
Wow.
Your vertex. What's other words for vertex?
Maximum.
Maximum. So you want to find the maximum of your y function, because y is like your height. So we're going to find the max of y. Do we know how to do that in your calculator? Same thing, but instead of choosing zeros, what do you choose this time? Maximum. I went way too far. That's okay. So what is our maximum height? Oh, excuse me. When is it the maximum? So when is it the highest in the air? At 6 seconds. So not what is the maximum height, but when is it the highest? Because when is it the highest in the air? So the y value there is the height that it is at that point, but the x value there is when that actually happens. So when t is 6, and that's what it's asking for. So when is it the highest? 6.
X is 6.
Yes. That's your t value. At 6 seconds. Questions? Alright, so we've got just a couple more that we need to get through. So for these problems, you're going to have to build your functions. So you've got the formulas on how to do that right here. So we basically just need these two. And the only thing that you really need to know is this v sub 0 is your initial velocity. So they're going to give you that. And then, do y'all know about like gravity?
Yeah, 9.8.
If you're in meters, what if you're in feet per second?
We don't care about that. We don't
16. So it's always going to be negative 16 t squared.
Negative 16.
Okay. 16. Because that's, if you're in feet per second, then it's always going to be 16 right here. And all of these are in feet per second, so we're good with that. So we're going to go ahead and build our functions and solve these problems. So for the first one, an object is thrown with an initial velocity of 170 feet per second at an angle of 30 degrees. So we need to write our parametric equations. So if you look at both of these, you've got to have your velocity times the cosine of your angle and your velocity times the sine of your angle. So I think it's helpful to go ahead and find those two things, especially because we don't have a ton of room here, just so that we could write our final equations instead of having so many parts. So what is our velocity? 170, so we'll do 170 times cosine of your angle, and what's our angle? 30 degrees. So mine's not in degrees right now, so I'm gonna have to change it. But that's okay. So we get 147.224. Is that okay? So I mean, just type that in your calculator, you'll see it. I know there's like a glare on mine that's hard to see up here. So we just did this part, your velocity times cosine of your angle. Yep, so for x, I guess I'm going to write it out. We did 170 times cosine of your angle, which was 30, times t. So that's going to give us x equals 147.224 t. And that's your x function. Is that okay? So that stuff just came from typing this in the calculator. You got to be in degree mode because your angle is in degrees. Questions? So we're going to do the same thing for our y function. We know that the first part is going to be negative 16 t squared because we are in feet per second, and that's your force of gravity. So negative 16 t squared. Then the middle part, when you're doing your velocity times sine of your angle, I'm just going to type that straight in the calculator, and we'll get that number and plug in here. Does that make sense? Well, this whole thing is 16, so it's going to be like 32, but the whole thing is just negative 16. Yes. Yes. So that whole thing, you just got to know it's negative 16 in the front. Really 32, yes. So we're doing 170 times sine of our angle, which was 30. So that gives us 85. So it's going to be plus, we got 85 in here, t plus your height, which ours was 0 because it didn't tell you a height that it started yet. So we can write plus 0 or just leave it off. What do y'all want to do? Leave it off. Okay. Questions? You won't have to build these functions on your test or on your exam. Does that make you feel better? Okay. So the next part wants to know how long is it in the air. So how are you going to figure that out? How long is it in the air? Which one's going to show you it coming up and coming back down? Y, right? So you're going to use your y function, and it wants to know how long it was in the air, so figure out when it hits the ground, right? So just find your zeros of your y function. So we're doing negative 16x squared plus 85x. So analyze your graph for your zeros again. So when did it hit the ground? 5 point what?
3-1.
Are you sure? I got 3.7. But I've done that problem a lot of times, and I've got 3.7 each time. Yeah. Oh my gosh, it moved it. Did y'all see that? I don't know. My calculator moved the graph. Look at it. Look at the function. It changed it. That's totally not what I typed in. Okay, so 5.31 is correct. My calculator's tripping. Is that okay? Y'all got 5.31? My calculator's wrong. So for C, what is the maximum height? Which one are you going to use, X or Y? Y, because Y is talking about height every time. So it wants you to find the maximum, so find the vertex there. My graph is jacked up, so I can't use it. 16x squared plus 85x. Yes, your maximum height. So that would be the Y value there. 113. Is that okay? So when you find the maximum of your Y function, it wants to know the maximum height. Not how long it took to get there, but what the maximum height is. So what is that going to be? 113. Is that okay? Then part D wants to know the distance traveled. So the distance is going to come from your X function, right? So how long was it in the air? 5.31. Plug that into your distance function. That's going to tell you how far it traveled. Does that make sense? guess so, maybe. Okay, so we're going to say x equals 147.224 times 5.31. And what do we get? So I just did 0.8. Is that okay? If you want to go two places, you can. I don't really care. Questions on that? Alright, so the last one, your object is thrown with an initial velocity of 50, so that's our v sub 0, and a height of 6, so you're going to have that plus 6 at the end, where last time we didn't have anything because they didn't tell you a height. And it's thrown straight up. So what angle is going to be straight up?
90.
Okay, so we need to write our functions. So for the x function, you're going to have your velocity times cosine of your angle. So our velocity was 50, so you're doing 50 cosine of 90, correct? I'm going to write that down here. So we did 50 cosine 90. And what do you get from your calculator for that? It's 0. So your x function is just x equals 0 times t, so it's kind of irrelevant on this one. Then for your y function, we're going to have your velocity times sine of 90. And what do you get from that? What is sine of 90?
50.
Well, sine of 90 is 1, so 50 times 1 gives you 50. So then when we go write our y function, you're going to have y equals negative 16t squared plus 50t. And what was the height that we started at?
Plus 6.
So plus 6. Is that okay? I know we're going through this really quick, but it's like about time to
What does
go.
the x say? Is that x plus?
0 times t, so it's irrelevant. Yep, negative 16. It's always got to be negative because you're going to go up and come back down, so your parabola has to be upside down. So for the next part, it wants to know how long it was in the air. How do you find that? Graph your function, find your zeros. Do you know what it is? You get 3.24. We don't really have time to do this, so I'm just going to tell you where it happens. So those are your zeros of y, just so you know where that's coming from. And then it wants to know your maximum height. How are you going to find that?
Graph.
The maximum of your y function, and that happens at 45.1 is your maximum height.
So would you
Yeah, from 0, 0, all the way, because that's when time starts at 0, because you're not going to have negative 1 second. Does that make sense? All right, so I'll give you homework.
we'll do the easy one that doesn't require the calculator.